Here we're supposed to make a table, and I'm only going to go 1 through 5. Make a table for this function that involves some factorial in it. So one thing that you can do is just go ahead and start substituting in numbers to the factorial, and then hopefully we'll see a pattern and we can simplify our work a little bit. So if our input is 1, then what we want is 1 plus 5, which is 6 factorial. So we're going to get 6 factorial divided by, again, our n is equal to 1, so 1 plus 3 is 4 factorial. Now if we expand this out, we know that 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And on the bottom we know that 4 factorial is 4 times 3 times 2 times 1. So all of these factors, top and bottom, that are 4 and less are going to reduce, and we're going to be left with 6 times 5, which is 30, so our first output is 30. Let's do that again with an input of 2. So if we have an input of 2, then we're going to have 2 plus 5, which is 7 factorial. And then we're going to divide by, our input is 2. 2 plus 3 is 5 factorial. And if we expand that out, then we're going to get 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5 factorial. We're going to divide that by 5 factorial. So instead of writing them all out, I've just stopped where I know I'm going to be able to reduce from the denominator. So the 5 factorial on the top reduces the 5 factorial on the bottom, and you're left with 7 times 6, which is 42. Now let's go back and let's do that to our original function up here. Let's simplify it the same way that we did when we had numbers to substitute in there. So another way to write n plus 5 factorial is to write n plus 5 times the factor that is 1 smaller than it, which would be n plus 4, times the factor that's 1 smaller than it, which would be n plus 3. And I see that I have n plus 3 factorial on the bottom, which is going to be n plus 3 times n plus 2 times n plus 1, and it's going to keep going in that direction. So that's what I want to reduce. The same way I reduce the 5 factorial with the 5 factorial, the 4 factorial on the bottom with the 4 factorial on the top. So I'm going to stop right here. Instead of continuing to write the factors, I'm just going to call it factorial at that point. So then I'm dividing by n plus 3 factorial. Factorials that are the same are going to cancel out because they have all of the same factors. And what's left is n plus 5 times n plus 4. Let's go back to the 2 examples that we worked and see that work for them before we trust it for any others. So with my reduced form of my f at n, if my input is 1, then I'm going to have 1 plus 5, which is 6, times 1 plus 4, which is 5. So I end up with 6 times 5, which is 30. Let's try that again for the second input. So my input is 2. If I put 2 in for the n, then I get 2 plus 5, which is 7. That's what we had here. 2 plus 4, which is 6. And 7 times 6 is 42. So we get these same answers whether we substitute in and then reduce, or whether we reduce our rule and then substitute in. So you can use either one of those methods to finish your table. So if I use 3 in here, then I get 3 plus 5 is 8, times 3 plus 4 is 7. 8 times 7 is 56. If I put 4 in here, I get 4 plus 5 is 9. 4 plus 4 is 8, and 9 times 8 is 72. For one more, if I put 5 in for n, 5 plus 5 is 10. 5 plus 4 is 9, and 10 times 9 is 90. And I can continue in that manner. Now the next part of the problem that we had said to write the closed form and the recursive form for this table once you developed it. We have already talked about what happens when you have first differences that are constant and second differences that are constant. If you have second differences that are constant, you know you have a quadratic. We know at this point right here when we reduce the rule for the factorial function that this is going to be quadratic, because if we expand this out, n times n is n squared. Our inner term is 5n, our outer term is 4n, and 5n plus 4n is 9n, and then 5 times 4 is 20. So this is actually our closed form right here. And to write the recursive form for that, then we could just go back to our table and follow our steps for writing a recursive form for a quadratic, which is in a different video, and you can go back and watch that.